Welcome. This is task 6.6 called Digging It. The idea is placing stakes around a circle, and you've got one suggestion that the distance between the markers of each circle being equal to the radius. This is essentially 1 radian, putting them 1 radian apart. And then Javier says, well, that's going to depend on how far away from the number of markers is going to depend on the radius, how far away. Do you agree or disagree? We disagree. The circumference of every circle is 2 pi times r, right? So the distance around the circle will always have 2 pi radians, 2 pi times that radius. So as an example, on number 2, show where the stakes would be located if there were placed on a circle 12 meters from the center and another one with 18. So each of these needs to be the distance of 1 radius. So for example, if the radius is 12, that means that the distance of this arc would be 12. And then you would have another one that would also be 12, and so on. And what you can see is there is approximately 1, 2, 3, 4, 5, approximately 6 radians around the circle. So about 6 radians. But exact, you can see it's a little bit more here at the end, so it's exactly 2 pi radians around the circle. And that's also the same even if the radius is greater, 1, 2, 3, 4, 5, 6, a little bit more than 6. So you're always going to have 2 pi radians that go around the circle. Okay, so the next one is trying to work this out on a grid. This case, there's 12 stakes around the circle, and you want to record the distance around the circle, as well as the xy coordinates, as well as the arc length from points 12, 0, and also 18, 0. So a couple things here. First thing is we need 12 stakes, right? So we've got one, actually count this one first. I'm going to use the 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we split it into 12 equal parts. So we know the circumference is 2 pi r. So on the radius of 18, we know the circumference is 36 pi. All right. And if we're trying to figure out that split into 12 parts, we can do 36 pi divided by 12 is equal to 3 pi. And you can see there, therefore the distance is 3 pi. Same thing over here with 2 pi. Circumference is 2 pi r, so circumference is 24 pi. So therefore the distance would be 24 divided by 12, or it would be a 2 pi distance, arc distance around the circle. Now, to find x and y points here for each of these going around, we go back to the idea, and we're going to use come on, almost got it. There we go. We're going to use degrees here in terms of calculating our xy coordinates, although we could later, we'll end up using radians, but for now we just use degrees. So we've got the x is r times the cosine of theta, and the y is r times the sine of theta. We got that from the ratio of cosine, x over r, and sine, y over r, from a triangle. And we're going to say theta's going to be reflected in terms of degrees. So we're going to be looking at just one reference triangle here. first. Here it is. We know it's got a 30-degree reference angle. So what we need is the x and y values for this. So if we're looking at the one with a radius of 18, the x, r cosine theta, would be 18 cosine of 30, which that works out to be about 15.59. And then the height, using the sine function, 18 sine of 30, works out to be exactly 9. Okay, you may know the 30, 60, 90 triangle, half of the hypotenuse, which is 18, would be 9. Same thing for the one with the radius of 12. It's approximately 10.39. However, if the radius is 12, hypotenuse, the side opposite the 30 degrees, half that, so it will be exactly 6 in terms of its location. Okay. Again, the 2 pi and the 3 pi, these were the arc lengths. And so now we have a method that we can use to find the x and y values. Radius times the cosine of theta for the x, and radius times the sine of theta for the y. Now, when you start to build this, let me pull these down here. There we go. So when you start to build these, for both the radius of 12 and 18, let's go ahead and add. The one for 12 we had is 10.39 and 6, and the one for 18 was 15.59 and exactly 9. That's the location. The distance that we measured was 2 pi and 3 pi, and the ratio, and this is the arc length, and the ratio of that arc length divided by the radius, which was 12 or 18, that ratio was pi over 6. Same thing, same ratio for the radius of 18, because we had 3 pi divided by 18 is pi over 6. This represents radians. So the big summary piece here is that the ratio of the arc length to the radius is the same for every circle, and that ratio represents radians.